Dear learners, in this session we will deal with states of matter. Now, as a human being, we are residing in a universe. So, the number of objects that we are observing around us are the basic constituents of the universe. So, the all substances which in unite makes up the universe is known as matter. That may be a molecule, that may be atom and ion, and these particular molecule atoms and ions which are in turn made up of proton, neutron and electrons. All these atoms comes together to form a molecule, and we can say that these molecules are the building blocks for all types of matters. Both the atoms and molecule are held together by a certain kind of potential energy. So the form of that potential energy is called as chemical energy. Unlike your kinetic energy, the potential energy is stored in an object, whereas in case of kinetic energy, that energy deals with the objects which are in motion. So this potential energy which allows your molecules or atoms to be kept in contact with one another, this potential energy is called as chemical energy. So the matter exists in a distinct physical forms. These distinct physical forms of matter that can take almost in any environment are referred as states of matter. You can also call it as a phase. Sometimes that the term phase work as in a synonymous to the state of matter. But the difference between state of matter and phase is a system that can contain a several immiscible phases of the same state of matter. Basically, there are three states of matters: solid, liquid, and gases. Nearly every substance can exist as one of the three main states depending on its temperature and pressure. The solid has a different kind of properties like your liquids and gases. So the basic properties that segregates solid, liquid and gases we will observe on the next part of your states of matter. But I will tell you that the relationship between these three states of matter is dependent on the temperature and pressure applied on them. The basic properties that differentiate your states of matter, solid, liquid and gases are packing, force of attraction, the various kind of bonds that allows your material to be in contact with one another, how it looks alike, how your solid, liquid and gas looks alike, and how much amount of volume they are going to occupy. That will be deal with properties. The next thing is when we are applying some kind of pressure over it, then the deformation may take place. Then how solid, liquid and gases differentiates in terms of compressibility, and how the motion is associated with all the solids and liquids and gases. The first property is packing. The packing arrangement within your solid is very close comparative to liquid and gases. Liquids are loosely connected to one another comparative to solids, whereas gases are kept much more apart from one another. And that's why the force of attraction that exists in case of solid is stronger, and which goes on decreasing as the packing arrangement goes on changing from solid to gases. Solids are much more stronger than liquids and gases. The force of attraction that allows two gas molecules to be in contact with one another is very negligible. So the force of attraction that holds this solid, liquid and gases will ultimately give shape to them. Solid has a fixed shape, whereas your liquid will have the shape of your container, the container in which you are going to pour that liquid. And same for the gas. Means you can say that though solid has a fixed shape, the liquid and gas won't possess a fixed kind of shape. And all of them, solid, liquid and gases, do has influence of volume. The container in which you are going to store them, the solid has a fixed volume as the force of attraction between them allowing them to be in close proximity to one another. We have seen that their packing arrangement is much stronger in case of solid. Thus, the volume of solid and liquid is fixed, which is not applicable to gases. As you are applying some kind of pressure and you are trying to compress the basic structure of matter, then you will observe that as the solids are closely packed with one another, they are having strongest force of attraction between individual molecule, and thus it makes them non compatible to compressibility. If you are applying pressure to the highest extent, then you can observe negligible compressibility, whereas in case of liquids and gases, the compressibility ratio is much higher. In case of gases, the particles are attached to one another by the less kind of force of attraction. They are kept in much more distance over one another. That's why by means of application of pressure, you can reduce that distance and you can keep that two molecules, that whichever constituting your gas molecule, the two molecules will come in contact with one another and you can transform them, and thereby the density will alter from solid to gases. The density of solid is highest, comparatively less in liquid, whereas least in case of gases, and thus make them non-movable. So obviously the kinetic energy will decrease from solid to gases, whereas solid has a very small kinetic energy and gases has highest amount of kinetic energy. Means gases can move accordingly in a fast proportion rather than your solid, and same is for your diffusion rate. The example that I will quote for the differentiation of solid, liquid and gas is your water molecule. You can have the water molecule in solid phase as ice if you are lowering that temperature and pressure. In case of liquid, your water, and in case of gases, you are having water vapor. So, this is about various properties of solids, liquid, and gases. All these solid, liquid, and gases can convert from one to another. You can have the change in state of matter, you can have transitions in that state of matter. Whatever solid, liquid and gases, they can undergo transition directly into either of the two classical states. Solid can convert into liquid and that can convert into gases. Liquid can convert into gas and solid, whereas gas can be converted into solid and liquid. There are various processes, there are various mechanisms by which you can convert solid, liquid and gases into one another. We will observe them one by one. At the start, let's see if you need to convert your solid into liquid and vice versa. If you are willing to convert your solid into liquid, then you need to go for the mechanism called as melting or fusion. Melting or fusion is a physical process that results in the phase transition of a substance from solid to liquid, and this occurs only when the internal energy of the solid increases. And how you can increase this internal energy? You can increase the internal energy typically by the application of heat or pressure, which increases the temperature of substance to the melting point and converting your solid into a liquid. In a vice versa condition, you can convert the same liquid into solid, and the process by which you can convert your liquid into solid is called as freezing. Freezing is a phase transition in which a liquid turns into solid when its temperature is lowered below its freezing point. Remember, in case of conversion of solid to liquid, you need to apply temperature to the melting point, whereas in case of liquid to solid, you need to go for the temperature below its freezing point. And this is the way by which you can convert solid into liquid or you can have liquid into solid. Now let's see how can you convert liquid into gases or gases into liquid. The process by which you can convert your gas into liquid is the process called as condensation. Condensation is the change of the physical state of matter from gaseous phase into liquid phase, and that is reverse to the vaporization. So, what vaporization does? Vaporization allows your liquid to be converted into gaseous phase. Vaporization of an element or compound is a phase transition by which you can convert your liquid phase into a vapor phase. Remember, in between your liquid and vapor are much denser for the volatile material. So you can easily condense your liquid from the vapor state. The next case, if we need to deal with the solid and your gases, you can ultimately convert your solid into gases and you can have gas into your solid phase. So, for the sake of conversion of your solid into gases, the mechanism is known as sublimation. It is a transition process whereby your substance directly goes to the gaseous phase. Means without converting into liquid phase, that will directly lead to the gaseous phase, and the process is known as sublimation. In the same way, the transition of your gas from solid may occur, and here you are bypassing the liquid phase. So the process by which you can convert your gas to the solid is known as deposition, and this deposition is the reverse of sublimation, and hence sometimes it is called as desublimation. So this was about states of matter. Thank you.